what I want to do now is compare sort of this XGBoost classifier to some other models, okay? So what I'm going to do is sort of turn this into a function. And the function sort of requires these core components. So when you're doing that, I think it's okay to copy it, right? So what are we going to call this? So sometimes I'll use CLF. This is a classifier. Keep it simple and short. And what's the input going to be here? I think the input is going to be the model, right? And so we're just going to input the model. And then what do we do with the model? Well, we get the scores, right? And you can see that these are relatively even, so I'm not going to worry about that. Let's just return the mean. Okay, let's just focus on that. Okay, so this looks good for the classifier. Let's go ahead and run the function, and then we'll try it using XGBoost. And so you do something like this, see that we get the same score, model equals XGB classifier, and then CLF, and then I can go ahead and run the model on it. Okay, and then we should get the same score back. Let's see. And we do. Okay, so this is good. Okay, let's just do some different comparisons. So let's try logistic regression, right? We can use any classifier here. So from sklearn we'll call it in linear model because it's like curve fitting, logistic regression, import it. Okay, and then we want to initialize it. And the reason why I'm going to, you don't have to do the initializing here, but I like it because, recall with logistic regression that this max iter, this is a small data set, so we'll just go with 5,000. That has been a good one for me. And then let's see how it does. Okay, so we're always going to run the CLF on our new model, and it does a little better, okay? So we get 83%. Okay, next, and logistic regression is a great model. Anytime you have classification, you want to use logistic regression. What else do we have? Let's try from sklearn.tree. Let's just try a single decision tree. Now it's got to be a classifier here. And I mean, if you like, you don't have to have that extra model line. Like you'll see why later I do. But CLF, okay, so I want to use a decision tree classifier. Now, let's just see what happens if we don't. Like so far, we're just using all the defaults. We're not making any changes to the models. So let's see how this does. Okay, it's not bad, 76%, And now let's try the random forest. So from sklearn.ensemble, I'm going to import the random forest classifier, and let's just put it in there, CLF random forest classifier. See how we do. And we get 0.80%, again, slightly better than XGBoost, okay? So at this point, you're probably wondering why the emphasis on XGBoost. Well, what we're going to do next is we're going to look at where XGBoost does have an edge, I think, over all of these, definitely over the logistic regression and also the decision tree classifier is in the tuning of its parameters, okay? It really has a lot. Now, we could just consider one of them, which, a couple to start with. Like, let's just do some comparisons using max depth, okay? So, I can run CLF, let's do XGB classifier, okay? And let's change the max depth. Now, remember, XGBoost is sort of, by design, turning a weak learner into a strong learner. So making this smaller is actually advantageous. I think the default is 6. We'll find out. You can even try 2. Like sometimes 2 can even be good. So let's see. It does have a slight improvement from the 78. What if we do 4 here? Not quite as strong. What about 3 maybe? No. What about 1? Yes, it does better with 1, okay? So that's interesting, right? This is classically, wow, it's only asking one question, but it's learning, a lot as it goes forward from training on the errors of that question. So that's fascinating. Those are called stumps, by the way, when your decision tree only has one, layer. Now let's compare that with the decision tree classifier. So for the decision tree classifier, you've got to have it be like relatively strong to gain something. But if you don't limit it, it can overfit. So let's try something like 6 and see what we get. Okay. Now, if we go lower, is it going to get worse or better? Let's find out. About the same. What if we go up to 8 here? Yeah, see, it's hovering around these percentages. If you go too low, it's not going to do well because it's only one decision tree. Okay, so it's doing the best that it can. I'm hovering around the 70s. Now let's try the random forest. Okay, so we put in a random forest classifier. And let's change the max depth here. Now the random forest is going to average all the decision trees together. So again, you don't want to go too low. You could try something like 4. Okay, and you can see it improves from its original close to the XGBoost one. And then, we could try, well, does it do better going smaller or higher? So if we try 2, it actually does do better. So that's interesting. So we're finding a lot of gains from not that much of a max depth. Wow, this is really fascinating. So this is sort of what you see often, is that once you start tuning parameters, random forest and XGBoost are legitimate sort of like competitors. They're both tree ensembles and they both have nice parameters that you can tune. So we've discussed random forest already. What we're going to do next is we're going to look at the wide range of options in XGBoost, and we're going to look at optimal methods to actually find great combinations of hyperparameters.